Now, in this video, we're going to take a look at a couple of things and kind of tease apart the foiling of a binomial with a binomial. And one of the techniques, we talk about this box method. So if you set up one of the binomials along one side of the box and the other binomial along the top edge, what you're going to do now is multiply this by this, and you get 4x squared. Now you multiply the 4x times the 7 and get 28x. Now you're going to multiply the 5 times the x and get 5x. And then the 5 times the 7 and get 35. Now, since all of these terms were positive, we don't put a plus here. But when we want to display this, we're going to see, are there any like terms? Well, these two terms are like terms. So we're going to go 4x squared, which is what we have here. We're going to add these two like terms together. This gives us a positive 33x. And since we're introducing a new term, we have to use the plus sign to separate terms. And then this is our last term all by itself. So we now have a trinomial that was the product of multiplying these two factors, binomial factors. All right, now let's look at this a little further. Now, we said in another video I sent out that in the box method, a way to factor a trinomial was to take your first term and put that here. And to take our last term and put that here. Then we said what we should do is multiply, and remember this is ax plus ax squared plus bx plus c. Multiply the a term, which is the 4, by the c term, which is the 35, and that gave us 140. Now we're going to factor this 140 as best we can. 2 goes into there, and that's a 70. 2 goes into there, and that's a 35. Now 2 or 3 doesn't go in there, but 5 will go into there, and that'll go 7 times. So we have done what is called a factoring tree, where outside here are the prime factors of 140. Now, what we want to do, looking at our b term here, which is 33, how can we combine these factors so that the factors would add up to 33? Well, we can go 4 times 35, but that wouldn't add up to 33. So we have to look at it a little bit more. How about if we do these two together and then this one? Now this is 14 times 2 is 28, and 5, that would add up to 33. So again, we're giving you a sort of a breakdown of what's going on behind all of these multiplying binomials, getting a trinomial, and then factoring the trinomial that we get. So here we ended up with a 28, and that'll be a 28x, and then a 5x. Okay, so I wanted you to see where we got these factors from. Again, we multiplied a times c, got the 140, and then we did a prime factorization. So I'm going to erase this. And now we're going to look at what we have in the boxes here. And I'll go back to red. I like red. Now, what can we factor out of each of these two terms going horizontally? Well, we can factor out an x. What can we factor out of these two terms going horizontally? Well, there's a factor of 7 in each of these. Now, how about this way? What can we factor out of each term? And if you said a 4x, you are correct. And what can I factor out of these two terms going this way? And if you said a 5, that is correct. So in a sense, what we've done through this box method is undo what we did over here. Now you'll notice the factors are coming out. We had some along this way, some along this way. It could be this way or that way. So what are our factors here? Well, it's going to be x plus 7 this way, and then this way, 4x plus 5. So we're showing you that you could use the box method to actually multiply binomials, and then a slightly different way to use the box method to multiply, in a sense, to factor into its factors. And this is a modification, in a sense, of that AC method that we spoke of. Okay, now again, of course, trying something like this on your own, that's the proof of the pudding.